I will start the recording now. Right? All right, so you don't have all that upfront stuff in the video. All right, so let's put this together. Now, by the way, if there was any questions there that somebody wanted to ask along the way in the beginning, feel free to address it now. So, because we have a 10-foot piece of conduit, it's not a massive, but it's not small. 10 foot of conduit is pretty good. So sometimes it comes to play out that on the same piece of conduit, you're going to make two bends on it. For all types of different reasons, we have to make two bends on it. 90s happen a lot. All right. Sometimes you leave a panel and the ceiling's right here, so you can't keep going with the conduit. So 90s happen all the time, leaving panels. And then as you're leaving the panel, all right, you had to leave in that position because there was another conduit here and another one here and another one here. So you had to leave there. But then somewhere along the line, a little bit ahead of this conduit, right, you have your 90, and now you have to offset away from something, right? Because there's something here, some kind of object or something in the way. So this is a 90 with an offset on it. And that can go in any direction. So I will start by putting two boxes as we did yesterday. All right, and I'll put another one sort of a little bit higher than I was doing it yesterday because we're going to come up to it. And I've even seen this because of the sheet metal studs, right, that we have separating the walls, right? The sheet metal studs already come with a hole on it, and so we're going to use that hole to run our conduit, but then we got to get back to the box that we're trying to get to, so we got to offset back over to it. All right, so that's why I like this box scenario. It does happen a lot, but all right, now let's make our 90. So again, remember, just as a recap from yesterday and just to explain it, these boxes are fit with different types of knockouts on it, right? Just to 3D this. So we have a knockout, 1, 2, and 3 knockouts on this box. And same thing on this box here. I have 1, 2, and 3 knockouts over here. So the first things we have to do is pick where we're leaving from and where we're landing at. Right? Always remember that about conduit bending. Conduit bending requires you to make these decisions before you do anything. The second thing you have to do, and as I was saying yesterday, in my opinion, the hardest thing to do is learn how to find your measurements for this. So again, it requires you to decide where you're going in and where you're coming out of. Just for whatever, I'm going to pick the one here on the outside, and I'm 90, and then I'm 90, and I'm 90. And here's a thing, just as a consideration, I'm not going to try to make this offset up to that one, because now I kind of kill these two. If somebody was coming in this direction, then they kind of lose access to that. So instead, we're going to go into the one on the bottom. All right, now I'll try to make this as nice. There we go. Something happened there in the middle, but it's fine. So this is a 90 with a box, or sorry, with an offset. Now that I've said that box offset, I want to distinguish between an offset and a box offset. A box offset happens anytime that you're going to go into a junction box. All right, let me give myself a page here. We have a wall, and we have our junction box on the wall, and we have these knockouts. These knockouts are separated by a little bit. It's a ½ inch. So as you're coming with your conduit along the wall, you have to make a little box offset to get the conduit into that box. And I don't like that. It looks the same. And so you have to come up 0.5 of an inch. You got to come up a ½ inch. Now, there's a way to do this bend that you can come over here and use the conduit bending formula and use the 10 degrees and do rise times 6. And if you do 0.5 times 6, this will be 3 inches. And so you have your conduit that looks straight over here, and you're going to make your box offset. So you'll make your first mark. Again, remember, 2 to 3 inches from the front of the conduit is perfect. and then you'll make your second mark at 3 inches from that mark. And now you can bend your box offset. Take the conduit to 10 degrees on the bender, rotate it around, slide it forward, make the bend to 10 degrees again, and now you'll have what an offset is by definition, 2 equal degrees made on this conduit, and then it should look nice and smooth going into this pipe, into that box. That's a box offset, using 10 degrees and making these marks. But here's my advice as you guys go and become electricians, is don't use this little line method and that 10 degree calculation and start putting marks on your box offsets for conduits, because it's gonna look amateurish. All right, something that you're like, well, I'm an amateur, but you kind of want to avoid it a little bit sometimes. And sometimes you can't, because, hey, this is my first time doing it, and I want to treat it like that. I'm going to wire up a panel or something like that. Let's be safe. But here's one where you can get away from it a little bit. In the world of making a box offset, you should train yourself to know how to feel what a box offset is. Feel that you can take the conduit to 10 degrees, slide it forward just a little bit, and you can use the 10 degrees, but you don't need to be making those marks for it. It's one of those that you want to practice. I'm saying all that, coming back over here, to say this is not a box offset, this is an offset. All right, and this usually happens. Now, there's no determined number that, okay, from this number up, it's an offset, and from this number down, it's a box offset. But instead, I'll treat it this way. 0.5, half of an inch, going into a box, that's a box offset. Anything else is just an offset. Now, for the purposes here, I'm not going to use 1 inch or anything like that. I'll use other numbers. But now let's get into this bend that we're going to do. So we're going to do a combination bend. So now we have the 90 and we have the offset. Excuse me. They're both together. So now we have to consider both of the things that we did yesterday. So first thing we want to do is know where to get our measurements from. Remember, the actual conduit is not there. You're going to bend this conduit and it'll be there. I'm just showing it because I'm illustrating it. So you want to get the measurement from the back of this 90 to the landing of where you're going to be going. That's the first measurement that you want to get. So let's put a number here. And by the way, this number matters. It's one of the things that you'll learn is when I can make a bend and when I can't make a bend. For example, if the number between these 2 points was, let's say, 24 inches, and the size of this conduit that I'm using, let's say it's 1 inch, it's going to be very hard to put a 90 and an offset on a 1 inch piece of conduit within a space of 24 inches. So that number does matter. Keep that in mind. There are dimensional spaces where we just can't do a bend in. So that's the first thing, find the measurements. So we got this one, we got this one. Remember, this was how we treated the 90. And now we have the height or rise of this offset over here. So let's give this side a number over here. Let's go with 12. Again, all these numbers don't matter as long as we have numbers to work with. And just for space reasons, I'm going to erase that out a little bit so I can put a number here. Let's go with, what does that look like? That looks like about a 6 inch offset. Now we need 2 bits of information. We only needed 1 yesterday. Either I need to know the degree that we're making this 90, or I needed to know the size of the conduit. I didn't need both yesterday, but today we need both. We need to know what size conduit it is because we're going to need to find the gain. And we need to know what degree we're using for this offset so that we can know how to find the shrink. So let's use 30 because that's the easy one to go with. And let's use 3 1/4 RMC because that's the easier one also, which is, and now I'll just go over to the table. This is something that you should be now bringing with you or have written down yesterday. But I'll come over to it as well just to give you guys an opportunity to look at it. But for 3/4 RMC, that gain is 4 inches. And the multiplier that we need to find the shrink 30 degrees is rise times a quarter. All right, or 0.25. So this is a 4-inch gain over here, and this calculation over here is going to be R times a quarter. So now now that we have all the bits of information, and I'll pause there for a second if anyone has a follow-up question as you guys write that out. Now we'll get into the steps to take to get to the total for this. I remember we always want to find the total cut length. Let me lower this down a little bit. All right, so step 1 and step 2 remain the same. They're always going to be the same, which is add up all the sides. And I'm just going to shorten it now to just add all sides. Step 2, and I'll just explain this for Juan who had missed yesterday. For step 2, remember that rigid needs to be threaded and the threads need to be inside the box. All right, if not, we can't secure this conduit to the junction box. And so we need about a 1/2 inch on each side. That's a good number to work with. All right, that's just enough to be able to put a lock nut on there, but not too long that it starts to interfere with the devices that we might want to put in this box. So for that reason, we're going to add +1 as our second step. So we add up all the sides, and then we add 1 inch to that total. And now here's the system that I have. Feel free to change this, although there's not much we can change on it. You can either do step 3 first or step 4 first. I'll explain. Because I have to consider now 2 things. I have to consider subtracting the gain from this conduit, because there's a 90. And I have to consider adding the shrink to this conduit, because there's an offset. So I have to add at some point, and I have to subtract at some point. So because we're in the process of adding, we added up all sides, we added 1. Let's just do the adding as step 3. Let's just keep adding right now. And so we'll add the shrink as our step 3, which means, and don't forget it because I have even forgotten it as I'm teaching class, subtract the gain. All right, and as always, I'll do the first one with you. If you've already started to do it, great. I'll do the first one as a walkthrough, and then I'll give you guys one to do on your own. Always changing it up a little bit, making it a little bit harder. So if we add up all sides, very easy. We go 50 plus 12. That gives us 62. And now we're going to add 1 to that. And now we have to find the shrink first. Right? You have to find the number that you're going to add to this. So because the formula is rise times a quarter, this becomes 6, because that's what the rise is, times, and I'm going to convert that quarter to quarters, 0.25. And so it's 6 quarters. 6 quarters are $1.50 if you want to go that route, or it's 1 inch, 0.5. And now we can add all of that up. That way the next and last step will be just the subtracting. All right, so we make this first addition. We have 62, 63, 64.5. And now we're going to subtract the gain. In this case, again, we have the easy numbers right now. It's subtracted by the 4. Let me fix up that 4. Doesn't look great. And so we'll just put the total over here, right, which is 60.5. All right, pause there. Make sure everybody has it. And also, if anyone has any follow-up questions to this. All right, and with this, it's just one of those things. If you remember the steps, you're good. Now, you can remember the steps and slip up a little bit, but it's important to remember the steps. All All right, and of course, as always, as I say, the hardest thing is just finding these numbers, finding the numbers. Like, how do you get that number for that offset? You know, how do you know it's 6 there versus 6.5? It's just, it requires a little bit of knowing what these 90s are going to be. What's that? Oh. And again, this is only for RMC because we have to cut it at the length first and then make the bends. With EMT, how do you do it with EMT? Well, you just make this 90. Let it be straight out. Put your level right on that conduit. And then take a measurement to the junction box. Nice and easy. Now you make the offset. The offset will be way longer than the junction box. And now you can just cut it right at that junction. You can literally put it right there, put a little mark on it, take your hacksaw or saw or however we're cutting it these days. My day it was a hacksaw. And then chop it. EMT right in. Now, I would say this, for the smaller EMT, 1/2 inch, 3/4, 1 inch, even 1.25 is done on a bender, but hey, everyone hates it. So that's the least used conduit, 1.25 because of that feature. But when we get into the larger EMT conduits, like 2 inch, 3 inch, and 4 inch EMT, we also apply this method as well. Because it's just hard to do all that with these large conduits. Bend it, then set it, then get the level and find the offset, then set it and get the measure and then cut. With these large conduits, it just becomes difficult to do it. So you can do it also applying this method to EMT and just do it all in one shot as well. All right, if there's no follow-ups to this one, I'm just going to erase it because there's a lot going on here and I just want to leave this. And then I'll give you guys one to do on your own. All right, put the junction box here. Put the other one over here. And I'm not going to get too fancy with this bend. We'll just go one-dimensional. And now I'll put some numbers. All right, we have our measurements between here and here. Measurements all the way over to where the conduit's going to land. And just stretch that out a little bit there. Let's put some numbers here. Again, these numbers can be anything, so I'll use some fractions now to mix it up a little bit. We'll have 14.5 over here. And let's call this 6, and we'll keep it at, we'll call it a 1/2. No, let's go with 3/4 here. All right, let's make the height here 7. That looks about 7, not really, but that's fine. And let's make this now 45 degrees. And the gain over here is going to be for 1/2 inch RMC. And not to just go back over to the table, so I'll put the gain over here. Remember, the gain is now changed. Just yesterday we had continuation with the gain that we were using prior to, so we've changed it. Let me fix that 7 over here. All right. Okay, so as I did yesterday, I'll pause here, give you guys a little bit of time to work this out. I'll do it also myself, make sure we all have the right answers. If everyone has it, no one needs any more help, we'll move on to the next one. If you don't have it and we got to hang out for a little bit, we won't go to the next one until everybody's got it. Oh, and this was R times 1.4. Sorry, not 1.4. My mistake there. It was 3/8, which ends up being 0.375, so I'll just call that 3/8. If you use 375, it's also fine. So I'll put it, let's see, I'll put it right here. Total cut length is what we're looking for. And whenever anyone has the answer, go ahead and fire away. We'll see how we do. All right, what do we got?
75 and 5/8.
75 and 5/8. All right.
Yes.
We got a double on that one. 75 and 5/8.
Yes.
Yeah.
All right. Anybody got anything different? All right, let's walk it through then. Okay. So if we add up all the sides, all right, 60 plus 14, all right, that's 74, plus another inch and a quarter. All right, so again, 60.75, that's a way you could do it, plus, sorry about that, 60 point, just gonna walk through it myself, double check, because I always like to double check, plus 14.5, that gives us 75.25. Oops. Now we're gonna add 1 to that. So this becomes 76.25. We'll do it at the end. So we add 1. Now we got to find the shrink. So shrink, if you use the decimal, is going to be 7 times 0.38 because that's the rise that we have here. 7 times 0.38 equals 2.66. So let's stop there and do all the adding because we're in the adding process. So before we subtract now, we'll add all this up. 0.25. This is going to equal 78.91. And now we subtract the 3.25. So that's minus 3.25. And that will equal, very good, 75.66. Which, it's not a half, it's not 3/4, it's got to be 5/8. It might be 11/16, but we don't use the 16th scale. So 75.66 it is. Or, again, 5/8. All right. Does anyone need to see that again? Online or otherwise. All right, let's go over to the back-to-back 90. Let's go. Thanks. All right. A back-to-back 90 is a very common bend as well that happens in combination a lot of times. Again, the conduit is 10 feet long, so What happens a lot, this is the most common one I've seen, is where we'll have a junction box over here and there's going to be another junction box over here. But we don't want to run the conduit straight across this because there either could be things in the way, one, or this also becomes a very weak conduit. If you've ever seen them on the walls, they're always broken at this end over here or broken over here. Now, we're talking about one section, but if there was a coupling over here connecting these two pieces together, this is a good place where it snaps to. So these horizontal runs are not good. Better is to get this conduit down to the ground and then, whoops, that is not going straight at all. And then 90 back into the junction box. And again, like I was saying earlier, a lot of times the frame of the walls themselves have the knockout. And then again, I'll have another frame over here for this. And I'll just use this and write it up. So 90s with back-to-back happen on RMC. They happen on EMT when we're going through walls. Usually going through walls, we like to keep flexible conduits for all of these reasons, but I have seen places where we've had to use regular EMT. So that's just a scenario for one type of back-to-back 90. This is also another type of back-to-back 90 where I went this way out of this junction box and found my way over to this one. I couldn't offset, so I had to do a back-to-back 90. I could have had something right here and something right there that don't allow for the offset. So all these are back-to-back 90s. All right, but at the end of the day, what is a back-to-back 90? Two 90s. Doesn't matter what direction they're going, two 90s. So let's put a junction box. This time I'm not going to put the 3D on it. You guys are getting hopefully the concept of the knockout. The other thing with a back-to-back 90 is they don't have to be the same height. A lot of times they are the same height, but a lot of times they're not the same height. So I'll start there with one that's not the same height. And so we're going to come into the junction box and go into this junction box. This is not such a good 90 over here. I have a bit more of a radius there. Now, because this is a back-to-back 90, we're going to need to have that information. So I do like to two-dimension this one just to show, wow, that one was much straighter than the other one. Just to show that, right? We want to go from the back of this 90 to that junction box and from the back of this 90 to this junction box. But back-to-back also includes the back of this 90 to the back of that 90 as well. This is, in fact, in my opinion, one of the harder bends to make is two 90s on one conduit. The 90 with an offset, it's kind of easy. You make the 90 first always, and that guides you into helping you make the offsets. But back-to-back 90s are a little bit of a tough bend. All right, so we'll give these sides some measurements. As always, the measurements don't matter. So we'll make that 20 inches over here. We'll go with about an estimated 13 there. I don't use enough odd numbers. And then again, here the point between, or the distance between these 2 points matters. All right, if this was 20 inches, I don't care what conduit you're using, it ain't happening. Maybe half-inch EMT, yes, but it's just a little bit more malleable, easier to bend. But I need space to bend. I need the shoe of this bender to have room so that I can make that 90. What makes the back-to-back 90 hard is that I have to do that twice, so sometimes the handle hits the other 90. So I need space here between these 2 points. So let's give it some space. Let's put 42 right there between these 2 points. And now it is only a 90. So we're not worried about shrink anymore. All right, we're worried about gain, but it's two 90s. So we have to subtract the gain twice. All right, so let's set this up. Step 1, 2, and 3 only. And we'll run through the steps. Add all sides. All right, step 1 and 2, always the same. Plus 1 inch for the 2 half inches on each side. And then, last but not least, is we subtract the gain twice. All right, just to move ahead a little bit with time, I'm going to pause here and just let you guys try it because it is just the same that we did yesterday. With 190, we're just going to do twice at the end. It shouldn't be too difficult, hopefully. I haven't given you a conduit, realizing it now. Let me already make it a little bit, not really harder, but 3.25 is the gain for this conduit. But remember, it happens twice. So let's come up with the total cut length for this one, and we'll move on after that. Because while this is the hardest bend to make, in my opinion, it's the easiest one to calculate. All right, what do we got? All right, anyone got total cut length?
$69.5.
69.25, I'll take that.
I know, I was like, oh, that's much sorry. I'll take turns. You got the next one.
No, it's okay. One person. No, good. You guys take turns. All right, so making it easy, we'll just work this out. 42 plus 13 plus 20. All right, what's that? 33 plus 42 is 75. And then plus 1 makes that 76. We can stop there because we're going to be subtracting. And now 3.25 becomes 6.5 because we do have another 90 to consider. All right, and we're going to take 6.5 away from that 76, and thus we land at 69.5. All right, well done, well done. We have 2 more, and then we'll wrap it up for the night.
But don't you have 1 inch on each box?
No, not 1 inch on each box. It's a ½ inch on each box.
Oh, okay.
So we just add 1 inch.
Oh, okay.
Yeah, now if you happen to have done a little bit extra, always okay. Less is just the problem. So forgetting the 1, problem. If you added 2, not a problem so much. It might interfere with a device going into this box. Like if I'm trying to put a GFCI or a switch, they could potentially hit that thread. But I can always chop off the ends of those threads if I wanted to make them small.
I thought you were adding 1 inch on each box.
Oh, okay, good to go. No, yeah, ½ on each side only, just ½ on each. So a total of 1. Very good. All right. And again, in practical terms, if you had 70 versus 69.5, it would be fine. You can get through solving all that. It's if you had 1 inch less, 68.5, problem. All right, so now let's get to the next two. All right, we're gonna now involve saddles. All right, we haven't talked about saddles yet as individuals because we're gonna catch them up here with the 90. So we have the 3-point saddle with the 90 and a 4-point saddle with the 90. Now, these are the last two that I'm gonna walk you through combinations of, but potentially you can have other combinations. I mean, these are not endless. There are only a couple possible ways that this thing can happen. But for example, you could have an offset with a 3-point saddle. Can happen. But once I show you how to do all of these combinations, then any combo that you can make, you will have the instructions on how to do it, because in principle, it's just combine the singles with each other. So now I'm going to teach you the 3-point saddle method. And so if an offset went with the 3-point saddle, you would do the same thing that you're going to do, except no 90, and we just have to now have an offset in the front. Now, I would say a 90 with a 3-point saddle and a 90 with a 4-point saddle, especially the 4-point saddle. That is our least favorite bend to make. All right, the 4-point saddle, it's just very annoying. It's hard to find all the measurements and going back to the thing and making sure you're right. It's always that distance in the 4-point saddle, this middle distance of finding this, always very annoying, hard to, so we avoid it at all costs if we can. Sometimes, no choice, got to do it. The 3-point saddle also is one of those that happens. All right, same thing. We leave a panel, we're in a machine, or they call the electrical room, could be a machine room, bunch of panels, bunch of things. We leave the panel, turn our 90, and right here, here's a plumbing pipe that's just on the wall, doing whatever, sprinkler pipe or something. So now I gotta saddle over it. So common, good enough, it can happen. There might even be some other conduits here. Conduits going into this panel that we have to hop over. So 90 with a saddle, especially the 3-point. Sorry, I meant 90 with the saddles don't happen as much, but I would say the one with the 3-point happens a little bit more than the 4-point saddle. So let's set this up. It's not going to be too complicated in the drawing. Junction box over here, junction box over here. And now I actually want to put that junction box a little closer. It doesn't have to be that far away. All right, so we got the 90. We are 90. We're heading over, and now we're going to do a saddle, 3-point, and now we're going back into the junction box. So I'm going to draw this out, make this a little two-dimensional. All right, and get over to the junction box. So first, let's start with the hard part, as I've said, finding the measurements. Although in this one, not too hard. Now that we've done it a few times, you guys get the idea. All right, we do want to come over to the junction box. Remember, there's no conduit, so I'm just going to the junction box, finding the knockout, picking the one I like. Here we are. I'm going to figure out where I'm going to turn this 90 at, and now I have this measurement over here. And now once I figure out what the back of this 90 is going to be, I'll know to what point I need to go to till I get to this junction box. All right, our two spaces. So hopefully these have become easier now to understand how to find and work with, and when you get out there, you'll have to deal with it, but finding these numbers are part of the learning how to bend conduit. Finding the measurements, I should say. All right, and the distance between these 2 points will make it 48 inches. Both of these are inches. All right. Now, let's fall back for a second and explain how we made a saddle, because it's important for what we're about to do now. Whenever you make a saddle, a 3-point saddle specifically, you are worried about one number, and now let's just isolate the saddle. And you're worried about what the distance, and let me just tie it into this junction box here, is from this junction box to the center of where that saddle is going to bend. And the most common, or I should say the industry standard that we use, because you can use other dimensions here, you can use other degrees, But the industry standard is to make the center 45 degrees at 45 degrees. So the conduit will be bent at 45 degrees. And then the other two bends at 22 and a half. And because we make that 45-degree bend right at the center, I don't have any shrink to deal with, because this is what happens to a 3-point and a 4-point saddle, is shrink. You're going to lose some conduit, but it doesn't happen on this side of the saddle because we bend at the center of the object. It happens on this side of the saddle only. So you only have one shrink to deal with on the front of this bend. And the only degree that we're worried about to calculate that shrink is the one that we make at the center. And since 100% of the time the saddles are made with 45 in the center and 22 and a half on each side, this is the number that we're always going to use to calculate our saddles. All right, so I'm going to get rid of all that since we have a saddle down here. And so this will be at 45 degrees, meaning it's the rise times 3/8 that we used earlier. And now all we need is the rise that we went up for the object here, which is usually, and by the way, this is just another added thing to 3-point saddles, usually we don't make them very big. All right, you don't want to make a big 3-point saddle. This looks terrible on the wall, or just, it looks very, just an odd looking bend with this giant saddle. You know, if it's on the wall and it's coming out of the wall and coming in, it's just going to look like this giant triangle just sticking out of the wall. It's going to look terrible. So these are always relatively small. We're only going over a pipe or something like that. It can, obviously a pipe can be as big as 6 inches, 7 inch, 8 inch, or even 12-inch diameter pipes, but we try to avoid making saddles over a 12-inch diameter pipe. We try to find another route. If none is possible, then maybe do it. But so let's keep this height not too high. Let's go 6 inches there max, if possible. And now last but not least, we do need a gain for this. And we'll make the gain, you know what, we haven't used the 1-inch gain yet, which is 5 5/8. All right, that's a fun one. Remember, if you want to turn 5/8 into a decimal, divide 5 into 8. It'll become 0.625, just to show it here on my calculator. There it is, 0.625. So you can just simply make that 0.63. So this 5.63 as the decimal representation of 5 5/8. All right, and now how do we do this? How do we approach the... This is why I said once I showed you the first one, I can just walk you through the last two, because it's the same as the 90 with the offset. Same approach. Step 1, add up all sides. Step 2, plus 1. All right, so same for both. I'll just put it here in case. Add all sides. Plus 1, and again, that's half for each side. Step 3, same as the offset, which means add the shrink. Step 4, same as the offset with the 90 I meant, 90 with the offset I meant. And that's subtract the gain. Here again, just one time. So it's the same set of instructions on how to do this one as the 90 with the offset. I will pause here and try to get to that answer. All right, how'd we do? And by the way, just as advice, just to help you guys, usually what I like to do is just find the shrink first. Because that's always a decimal number because of the fact that I might have to deal with that. So in this case, I would do 6 times 0.38 first, figure out what shrink is going to be. Let me just make sure I'm not in the way there. Now I got plenty of space there. And it's going to be 2.28. So I got it now. Now I can just add up my sides, 48 and 11 and so on. Has anybody got a number for me?
56 and 5/8.
56 and 5/8. Okay. Yeah, we doubled that one. All right, 5/9 for all sides. Very good. Plus 1. Plus 2.28. We already got it. And the reason why I do it, by the way, is just for my calculator too, because I can just go 2.28 and then everybody gets added and then everyone gets subtracted from there. All right, 2.28 plus 1 and then plus 59. I could equal right there. I got 62. I'm going to bring the numbers here. 62.28 at that point without the subtracting of the gain. And now I'm going to take away that 5.63. And again, if you use the fractions, all good. We'll iron that all out when I grade them. I'll know if you were close or if, like, say for example here, you called that 56 and a half. I would give that the right answer. Yes, you're right. Not going to worry about 0.15 of a decimal. Now, if this was 54.5, then, you know, we're obviously in the wrong time zone here. All right, and again, that is 5/8 because we do not use the 16th of an inch. All right, 56.65. Well done. All right, before we move on, does anybody want to see this one again? All right, technically, you know, it's just a remake of the offset, just in a different way, or 90 with an offset in a different way. And again, this is specifically because we bend at this center. The only one that's causing is the 45, because this 22.5 over here gets us back to normal. So it's this bend right here. It's that pull right there that takes away from the front. All right, so last but not least, and then we'll wrap things up for today. Oh, by the way, just a reminder, tomorrow bring your code books. All right, bring your code books tomorrow. We are going to go through Article 344. If you like to highlight them, I'll have most of the article stuff here that's going to be important for us. Uses permitted, and I have most of everything here. So if you happen to forget it, it's not the end of the world, but then you'd have to go back and highlight everything. So my recommendation is to highlight your code book and just make it a thing that you're constantly working on. So that's what we'll head into tomorrow, so don't forget your code books. All right, let's wrap it up with the last bend today, and we'll call it a night. We're going to go with the 4-point saddle now. And again, this is a bend that doesn't happen as often as the other ones. This is a difficult bend to make. All right, to calculate out and just even find the numbers for these. But I would say not so much, you know, anything about the formula or find the method. It's the making of this bend. Right, you make the 90 first, and then you try to make a 4-point saddle. It's just going to be difficult. If you try to go the other way, make the 4-point saddle, and you try to line up the perfect 90, this is going to be hard. You got 4 places, and then you're adding a 90, 5 places where you can potentially get a wrong direction here or a slight off, and this just doesn't land very well sometimes. This is one of these bends that this takes practice. It takes a lot of practice to be able to learn how to make a 90 with a 4-point saddle on it. All right, but we're learning, and so as with everything in bending, it starts here. It starts at the understanding how to find the calculations. So let's place another junction box over here, and I'm going to lower this one just a little bit. All right, so again, you're coming out of the panel with the 90, and all of a sudden you have to make a 4-point saddle. And now you're coming into the junction box. Now, these look a little bit off, but both sides should match. Let's put a little 2-dimension to this. All right. And now, first things first, giving you time to draw this out if you are drawing this out. Just like with the 3-point saddle, all right? As I said, with the 3-point saddle, the most common is 45, 22 and a half, 22 and a half. But you could also make this 60 and then 30, 30. The point is to get back to even. And the way you do that has to be divisible by the center bend. This is why the bender put that 22 and a half function in it, right? Why would they have a 22 and a half? It's because 22 and a half, 22 and a half gets us back to 45. Now, we don't like the 60 because the 60 is actually really tight. So whatever object sits here, sometimes we can't get over each of the sides if we make the the center bend on a saddle too tight. You have another option here, which is 30, 15, 15. You can do 30, 15, and 15. And this is not terrible, except the only thing with this is it's going to make your saddle very wide. All right, so it's going to cover a lot of space here, and there could be other things in the way, and making a saddle like this just puts the conduit into more possible issues. And also, again, if this happens to be now a little bit wider, now you can potentially be way too wide and you have these large gaps on these sides and it just doesn't look good. So a lot of conduit bending is what looks best. So 45 is that Goldilocks zone. Not too hot, not too cold, just right. All right, it's enough of a wide to be able to get over an object with no problem and not be too tight on the object. But it's not so wide that it compromises the ways this is going to look. So that's why I say it's the industry standard to make a saddle with 45 in the center, but you can make it with those two that I just showed you. The other two I showed you, 30 center, 60 center. Now, for the 4-point saddle, same thing applies. All these are just two offsets on the same piece of conduit. With that in mind, you can make an offset with anything from 10, 15, 22 and a half, 30, 45, or 60. So this saddle can be any of those degrees that we want. They just all four have to be the same. It's the one thing with this. If this is 30 degrees, this is 30, this is 30, and this is 30. If you make any of them another degree, this becomes a wild looking bend. Now, same approach as before. The 30 is just going to make this saddle way too wide, and it's going to look terrible, and it starts to now affect other things around it. The 60 makes this saddle too tight, and now the object in the middle is not going to, potentially we can run into it, but more so is the higher degree bends we make, the tighter this conduit run becomes when I go to pull the wires. Now I have to pull between 60 and 60 and 60 and 60. These are too many tight bends. It could put a lot of stress on the wire. Tomorrow when we get into the code section 344, we will learn, and which you've already learned this before, we have a total of 360 degrees between these 2 points to make in bend. So I don't want to spend too much. There's another reason why we don't use 60, especially on a 4-point saddle, and we have to do it now 4 times. The total for the degrees used right there are 60 times 4. That's 240 degrees that you just used of our 360. And now if you add this 90, I'm at 330. Fine, but if I make any other bend, this goes beyond the allowable. So 45 becomes that, again, Goldilocks zone. It's not too wide, it's not too tight. It is 45 degrees, so it's in the middle of 30 and 60, so you're using some degrees, but not as much. So it's just the industry standard to make a 45 degree saddle. But remember, this happens 4 times. More on that tomorrow when we get into that code section. So 45 degrees is what we use for it, which means rise times 0.38 twice. All right, that's the thing with the 4-point saddle. It's 2 offsets, meaning if I lost shrink with 1 offset, I lose shrink twice with a 4-point saddle. And now the conduit, let's go with 3/4 RMC this time, because our multiplier is 4. And now we need all of our measurements as before. We need to know the height of the 90 over here. Let's make this 12 inches. Definitely the space between these 2 points has to be enough to accommodate a 90 and a 4-point saddle. So you're going to want some distance here. 60 is good. I can make it with that. Depending on the conduit, I would even say. And now all I need to know is the rise inside this 4-point saddle. So let's make that 8 inches right there in the center. And now this is the same as a 90 with an offset, except on step 3 happens twice. Add shrink twice. All right, we still do the last one, which is subtract the gain. It only happens once. There's only 190. And the first 2 you should already just have memorized. Add all sides, and then plus 1. All right, so again, I'll pause here, and a different student in the classroom. You guys doing great doing that. That way the teacher knows everybody's taking part in it. All right, teacher appreciation for you guys. All right, so let's do this math and see how we did. I think I got it right.
Okay, I think it's 75.08.
That's what I got, so if it's not that, then we both messed up. But I'll wait. If anybody else has another number, also share it just so I can, not embarrassing. I mean, maybe I'm wrong. Maybe we're both wrong, I should say. But, we're right. But just in case if someone's got a different answer, then I can walk you through it. So we'll walk through this. I'm gonna just erase a little bit of this here so I can have some space to write things. But I'll bring back the gain just as itself, 4 inches. So this one we had to do shrink twice. So let's just start there, because we had 8 times 0.38, and this comes out to 3.04. But it's going to happen twice, so the gain is 6.08. Let me get this way out of the way. And now we just come back to our numbers. 60 plus 12 is 72, plus 1. We can add at that point. 72 plus 1, 73, plus 6. This becomes 79.08. All right, and now we're going to subtract 4. And that's how we got our 75.08. In practical terms, when we go to our tape measure, we absolutely drop that 0.8 and becomes 75. All right, because that 0.8 is a 1/16 of an inch. Might even be a 32nd of an inch. But probably a 16. Or closer to. All right, is anyone sitting there with a different number? Going, what happened in this? No. All right, I'm going to go ahead and stop.